Good morning and welcome to Teacher Estelle's science class. Today we're still busy with the grade 7 curriculum, and as I promised in my previous video, I am going to visit the periodic table today. But before we do, I think it's necessary for us to just recap some of the concepts before we try and use them. Good. On the periodic table of elements, we have little square representations. We call those little squares, if you see one like that, it's a periodic table representation of the atom, of that specific element. A different way to show that is the cross section. Remember last time I showed you the cross section when we looked at the maximum electron distribution. Now the cross section is basically something like this, where we had all the different energy levels that we represented in a circular format. It's almost like concentric circles. Now when we do concentric circles with little dots, we call it the Bohr model. Niels Bohr was a scientist and he did it this way. He drew little circles to show you how many electrons there are on each energy level. But remember now, we looked at enantium last time. Now enantium, we've said, is a happy element, but it's also one of the elements that shows the maximum electron configuration. It showed us that there can only be 7 energy levels, and each energy level was full. It had the total amount of electrons that could be on that level. It was, remember I said you must go and study that. Right, so on the inside we've got 2, 8, 18, 32, 32, 18 and 2 electrons. But now you can imagine how many circles would I have to draw to represent this enantium as a Bohr model. I'll have to have 7 concentric circles, and on each circle I have to draw that amount of electrons in a little dot. Good. Now think about that. I'll have enantium will have 7 of these concentric circles with 2 dots, just like oxygen, in the middle on the first energy level. On the second energy level, I'll have to draw 8 dots. Then I have to draw a third circle, third energy level, to show that it's got 18 dots there. Then I have to draw a fourth circle, concentric circle, to show there's a fourth energy level with 32 electrons. So I will have to make 32 little dots on there. On the next energy level, I'll have to make 32 dots again. And then on the second last one, 18 dots. And on the last one, 2 dots again. Now you can imagine how long that's going to take me to actually fill in all those little dots on each of those energy levels. Good. For that reason, we have what we call a cross section. Cross section is basically, now this one, I just cut it in half, but I have to show all the information. Can you see that if I just fold it in half, I lose those electrons on that side. I lose that information. So I have to write it down. And for that reason, we've got those little numbers there instead of making little dots. Good. But this is the Bohr model. Now you can imagine if I just see a Bohr model of enantium, I see 7 concentric circles with 2 dots on the inside, 8 dots on the next level, 18 dots then 32, then 32. I'll have to sit and count all those little dots. And the chance that I might just miscalculate or miscount one exists. Good. For that reason, Dmitri Mendeleev decided to write all that information for each one of the elements on a little card like this. And these little cards is represented on the periodic table. Now let's just see what all of this means. If you look, I've used copper here because it's got not as many energy levels as enantium, but it's got more than oxygen, so it just gives you a bigger picture. Good. Now copper, in the middle they've got the element symbol. The element symbol of copper is Cu, and there they've got the element name. Now on this side, they have little numbers, 2, 8, 18, 1. Remember, we always start numbering from the inside out. We also start then from top to bottom. So copper will have 2 electrons on that energy level. It will have 8 electrons on that energy level. On the third energy level, it has 18, which is the maximum. And then on its last energy level, it will have only 1. But there's space for 32. So there's space for 31 more electrons on its outer energy level. So it can combine. Good. Now, if we just count how many numbers we have there, we have 1, 2, 3, 4, which means there's 1, 2, 3, 4 energy levels in the copper atom. Good. If we calculate all of these together, we add them together, we get a total of 29. Those are the amount of protons that will be in the nucleus of a copper atom. Good. That we call the element number. The element number is also indicated on the periodic table, which you will discover as we go along. Good. At the bottom, they've got an estimated atomic mass. Now, the problem comes in when we want to purchase a periodic table. Not all periodic tables have all the information. It depends what you want to use your periodic table for and what you want to research. Are you interested in the estimated atomic mass? Are you interested in how many energy levels or the electron distribution on each level? Or are you only interested in the protons in the nucleus or the atomic number? Good. So it depends what the scientist wants to use this periodic table for. Now, the electron configuration can also be indicated this way. There we can see it's got 2, 8, 18, 1, 2, 8, 18, and 1. Now, we use this when we describe this atom in a paragraph format. Now, that's a lot of work. It's a lot of words that you have to write for something that you can just illustrate like this. Here we've got all the information. As long as you know that that is the atomic number, these are indicate the amount of energy levels, and it also indicates the electron configuration. That's the element symbol. There you have your element name, and at the bottom you have your estimated atomic mass. Now, if you want to do that in a paragraph form, you'll have to write all of that information word for word. Let me try and do it. Copper is an element with an element symbol of Cu. Its atomic mass is 29. It has 4 energy levels with an electron distribution or electron configuration of 2, 8, 18, 1, and an estimated atomic mass of 63.546. That's a lot of writing to do. So, for that purpose, you can imagine Dmitri Mendeleev wanted to give all that information. He was writing a book, and he wanted to capture all that information for each one of the 120 elements. You can imagine that was a big job. So what he did is he wrote it on little cards like this. Good. This one you can see for oxygen. Let's just recap. That's the element symbol, the element name. That is the atomic number, which also indicates how many protons there are in the nucleus. Here's your electron distribution. It's got 2 energy levels. On the first energy level, it's got 2 electrons. On the second, it's got 6. And at the bottom, you've got the estimated atomic mass. Now, that is what he tried to put on his little cards. And he had 120 of these little cards because there's 120 elements. Good. That just makes it much easier. But now he encountered a problem. There are elements that fitted into the same spot. Now let's see how he laid out this periodic table. At this stage, the detailed information is not that important. I just wanted to give you the bigger picture of this. So we're not going to discuss all the little details. You do not have to see that and sit closer and zoom in to see that. Just listen very carefully as I explain it. Over there you might have noticed that we have the words rows or periods. Now, scientists discovered that these elements behave in different periods, or they appear, the electrons appear in periods. So they tried to organize them in that way. So what they did is they looked at the rows, they put them into rows. Now you can see some of the rows have blank spots. It's almost as if the children are absent. Okay, so there's one that stands in front of the row, and there's one in the back of the row, and almost like the COVID-19 virus, there's space in between. Okay, but that's still a row, right? So that's one row or one period, and then we have a second row. We've got a third row also with some children absent, and then we've got row 4, row 5, row 6, and row 7. I'm just going to close the last 2 rows. They're not numbered. I will come back to that in a second. What's important for you to think about now is how many rows did I count? Yes, there are 7 rows, but there are also, remember, 7 energy levels, right? So what does it tell us? That tells us that all our elements that's in a row have the same amount of energy levels. So in the top row, we have hydrogen and helium, which means they have 1 energy level, because we now know that hydrogen has 1 energy level. So all the elements in row 1 will have 1 energy level. The only two elements that have 1 energy level is hydrogen and helium. Hydrogen has 1 electron on its energy level, and helium has 2 electrons on its outer or its only energy level. If you look at row number 2, you can see every element in that row has 2 energy levels. Remember, we looked at oxygen, and we know that oxygen has 2 energy levels. And if we try and find oxygen, we look in row 2, because all the elements in row 2 has 2 energy levels. And if you go down the row, you will find oxygen there. Okay? All the elements in row 3 will have 3 energy levels. All the elements in row 4 will have 4 energy levels, 5, 6, and the last row, 7 energy levels for all those elements in that row, because 7 is the maximum amount of energy levels that there can be. But now you're going to ask me, but I saw 2 rows at the bottom. Don't worry about those. I'll get back to that. Keep it in mind. Good. What's important here? Think about it carefully. All the elements in a row has the same amount of energy levels. Easy way to figure that out, if you tend to forget it, is just count how many rows do we have. We have 7. You know the maximum is 7, so that shows you that all the elements in that row must have the same amount of energy levels. But remember I said when we looked at oxygen and we looked at how a water molecule is formed by 2 hydrogens and 1 oxygen atom, scientists are interested in the outer energy level, because that is where compounds are made. That is where atoms combine with other atoms of other elements, or even of the same element. Good? So, if you work in columns, columns work from top to bottom. Columns are also called groups. Now they grouped them together. All the elements in group 1 has the same amount of electrons on its outer shell. So we know that hydrogen has 1 energy level because it's in row 1, but it has 1 electron on its outer shell. But it has only 1 shell, but it's still its outer shell. If you go down the list, you will see that this element at the bottom here because it's in row 7, it will have 7 energy levels. But it will have the same amount of electrons on energy level 7. Because energy level 7 will be its outer energy level. And it will be 1. Okay, so there will be one electron on its last energy level. One of the elements here in row 5 will only have 5 energy levels, but it will still only have one electron on energy level number 5, because that energy level is then that one's outer energy level. So if you go down in columns, you will see that group 2, they all have the same amount of electrons on their outer energy levels, and same with group 3, group 4, group 5, and so on as you go along. Right, so let's spot oxygen again. All the elements in the same group as oxygen will have how many electrons on their outer shells? 6. Good. We looked at that last time. We know that its outer energy level, it is in row 2 because it has only 2 energy levels, and it has 6 electrons on its outer shell. So all the elements in that group will have 6 electrons on their outer shell. And this one at the bottom will have 7 energy levels with 6 electrons on that last energy level. Right, now I'm going to reveal these 2 rows at the bottom. Let's have a look. Maybe you can spot that they are in different colors, which makes it easier for us to place them. Now remember I said that Dmitri Mendeleev used little cards, because that's the only way he could explain where these elements at the bottom fit in. Now, if you consider that this dark purple row must go into that square, there's no way that you can take them off and put them there and in 3 dimensions on a flat surface when you publish a book, right? But imagine that you could have a little card for each one of these elements that is in this group, in this row here. You can cut them out, put them on top of each other, and then put them there in that space. Why? All these elements that you see here belong to row 6, which means all these elements here have 6 energy levels, but they all belong to group 3 because they've got the same amount of electrons on their outer shell as those in group 3. So if you look carefully on the periodic table, it shows you that this color, it's color coded to show you that all of these should go there. All right? And on my periodic table, it tells me their number 57 to 71. It's all of these. There it says LA to LU. That's the first one is LA to LU. So I can actually cut them up and concertina fold them and put them there. Okay? But it's difficult to put that on a flat surface if I want to publish it. Now the same counts for this row. Okay? It's not a second row or a 9th row. This is not row 8 and row 9. Remember, there can only be 7 rows because there's 7 energy levels. But all the elements in this group here that you've got here can be cut out, stacked on top of each other, and then fitted into that space there. On my periodic table, it says number 89 to number 103, which is that one and that one, which means all of those have 7 energy levels, but they have the same amount of electrons on their outer energy level, on energy level 7, as those in group 3. And that's not that difficult, is it? Okay, I hope you understood. I hope you can rewind if you're not sure, but take it one step at a time. Remember, columns, rows, all right? Columns are also called groups. Rows are called periods. And we know there are 7 because there's 7 energy levels. I hope you had fun. Maybe you want to buy or download a periodic table, then you have to evaluate them. You have to compare them and see, do they give you all the information you want, and which one is the best to use. I battled to get one that shows all our information that we need, that we learned about today. Have fun, stay safe, see you next time. Bye.